The warm summer night held the countryside in a deep, velvety embrace, a tangible silence broken only by the tireless, rhythmic chorus of crickets soaring away in the tall, freshly cut grass that smelled faintly of earth and sweet decay, a perfume utterly untainted by the harsh, upward glare of urban luminescence, leaving the celestial dome above an expanse of absolute, profound blackness against which millions upon millions of distant suns glittered with an impossible intensity, scattered like flawless diamonds across an infinite, unknowable fabric. I lay there, utterly insignificant yet entirely present, my breath slow and deep, an observer suspended between the humid terrestrial sphere and the icy, distant vacuum. For a fleeting second, I closed my eyes, surrendering to the darkness, and when I opened them again, the profound shift occurred, the cognitive rupture that was no longer confined to poetry or abstract philosophy, but had violently entered the domain of empirical science, the sudden, chilling realization that those pinpricks of light were not merely passive, billion-year-old fusion reactors burning hydrogen into helium across unimaginable gulfs of space, but that they were, in some terrifyingly active sense, looking back. Not with biological eyes, of course, but through the very emission of their light, through modulated flux and carefully constructed temporal patterns. An idea, audacious and bordering on madness, surfaced. What if some of these stars were not just existing entities governed by gravity and thermodynamics, but possessed an intrinsic intelligence, a self-awareness structured not in carbon and water, but in plasma dynamics and magnetohydrodynamics, attempting communication through the universe's oldest, most fundamental language, electromagnetic radiation itself? This narrative, sounding for all the world like the fevered dream of a romantic astronomer or the opening scene of a grand, terrifying science fiction epic, had, by the cold, hard calendar date of November 2025, metastasized into arguably the most pressing, paradigm-shattering discussion within astrophysics and theoretical physics circles globally. The concept of sentient stars, once relegated to the furthest fringes of fringe speculation, was now featuring prominently in peer-reviewed journals, dominating the abstracts of international conferences, and fueling continuous, often frantic, late-night debates across digital platforms like X, formerly known as Twitter. The true tremor began subtly, years earlier, in the crisp, clear skies of October 2017, when the venerable Kepler Space Telescope, a tireless sentinel hunting for exoplanets through the transit method, flagged an anomaly associated with a specific stellar object designated KIC 8462852, affectionately nicknamed Tabby Star, after the lead researcher, Tabitha Boyajian. Located approximately 1,400 light-years distant in the constellation Cygnus, Tabby Star defied expectation. Its luminosity dipped, not the gentle, predictable dimming caused by an orbiting planet crossing its face, but by staggering amounts, reaching dips of up to 22% in some recorded events. Crucially, these occultations were irregular, non-periodic, and maddeningly complex, suggesting the transit object, if it was an object at all, was colossal, perhaps structurally organized, and seemingly in a state of continuous, perhaps even deliberate, construction and deconstruction around the star. The initial scientific whisper was almost immediately laced with the most monumental implication. Could this be evidence of a Dyson swarm or even a complete Dyson sphere, the hypothetical megastructure hypothesized to enclose a star entirely to harness its total energy output, the calling card of a Type II civilization on the Kardashev scale? The feeling permeating laboratories then was precisely the visceral apprehension one experiences when hearing an unexpected knock on the door late at night, the heart hammering against the ribs, suspended between the relief of a known presence and the paralyzing fear of the truly unknown. But the true, earth-shattering explosion of this possibility arrived not as a slow burn, but as a supernova of data interpretation in the year 2025. This time, it was not one star, but a coordinated sweep involving the unparalleled infrared sensitivity of the James Webb Space Telescope, complemented by a vast, globally distributed array of ground-based observatories. They simultaneously targeted dozens of stars exhibiting behaviors even more complex than Tabby's. Among these was Assassin 21QJ, initially flagged by the Automated Supernova Hunting Project, the All-Sky Automated Survey for Supernovae. Early analysis suggested an imminent, catastrophic core collapse, a standard Type II supernova signature. However, as the temporal light curves were meticulously tracked, The variations in brightness began to resolve into sequences that possessed an undeniable, startling internal structure. Researchers at Stockholm University dedicated months, filtering noise and compensating for interstellar dust extinction, culminating in a paper released in September of that year that sent shockwaves through the field. They announced that the complex, multi-year dimming and brightening sequence of Assassin 21QJ could be systematically translated into a binary string millions of bits long. Upon decryption using advanced algorithmic processing, the resulting sequence was not random noise, nor simple mathematical constants like the ratio of a circle's circumference to its diameter, pi, which begins with 3.14159 and so on. Instead, the sequence appeared to be an iterative product of pi multiplied by an as-yet undetermined physical constant, presented in a non-linear, self-correcting format. Imagine sitting alone in the absolute blackness of an observatory dome, illuminated only by the dull, deep red safety light of a computer monitor, when that monitor suddenly emits a series of precise, structured beeps as the pattern recognition software locks onto a pattern originating from a star 6,000 light-years away. The experience described by the lead analyst was akin to receiving a perfectly formatted, meaningful message from a lost love after centuries of absolute silence, a blend of exhilarating recognition and profound, isolating dread. Simultaneously, and perhaps even more disturbingly for those invested in the physical mechanics of stellar evolution, a highly specialized team at the Max Planck Institute for Astronomy in Garching, Germany, released their findings based on observations made through the Atacama Large Millimeter-Submillimeter Array, ALMA, situated in the bone-dry, near-zero temperature environment of the Atacama Desert at night. Their target was the well-known red supergiant, Betelgeuse, in the constellation Orion, the star whose ruddy glow graces the northern hemisphere skies every winter. Conventional wisdom suggested Betelgeuse was an aging giant undergoing chaotic pulsations prior to its dramatic supernova demise. What the ALMA array detected, however, was far more organized. They observed that the magnetic field topology of Betelgeuse was fluctuating in patterns of staggering complexity, patterns that suggested active information transfer rather than the stochastic churning of superheated plasma expected from convective instability. Furthermore, spectroscopic analysis revealed extraordinarily narrow absorption lines, features usually smoothed out by the star's turbulent surface layers, that shifted with a precise periodicity of 6 to 7 days. These lines, according to the German team's initial quantum optical analysis, appeared to encode an optical cipher. A junior researcher, Sophia Schmidt, recounted the moment of breakthrough during an internal presentation. As her custom-built signal processing software executed the final decryption key, the output resolved into a string of symbols that bore an uncanny resemblance to the foundational mathematical notation for concepts like infinity and universal connectivity, loosely translated by the software as, "We are here." She later confessed that the meeting room, usually buzzing with quiet activity, fell into a silence so absolute that the only audible sounds were the faint, high-pitched whine of the cooling fans and the frantic, audible pounding of everyone's heart against the sudden weight of cosmic realization. The immediate, fundamental question that then gripped both the public imagination and serious academic discourse was, how, precisely, could a star, a monstrous ball of plasma governed primarily by the Navier-Stokes equations describing fluid motion under extreme pressure and temperature, possibly harbor or generate anything resembling cognition? We are taught that stars are merely sustained thermonuclear reactors, their internal states defined by gravitational collapse balanced against outward radiative pressure, operating across temperatures measured in the tens of millions of Kelvin in their cores. Where, in that searing, undifferentiated ocean of ionized gas, could the architecture for consciousness reside? Theoretical physicists, armed with the empirical evidence of structured light and magnetic fluctuations, swiftly advanced a radical, novel hypothesis, rapidly gaining traction under the banner of plasma cognition or Magneto-Consciousness. This concept pivots on the understanding that stellar plasma, at the extreme densities and temperatures found within a stellar interior, is not merely a gas but the fourth state of matter, a conductive sea where electrons are entirely decoupled from atomic nuclei, moving in vast, swirling, electrically charged currents. These currents inherently generate powerful, dynamic magnetic fields, which, in turn, exert Lorentz forces that dictate the motion and organization of the plasma itself, creating a colossal, self-regulating feedback loop. Professor Levin Matsars and his colleagues at the University of São Paulo proposed that if this feedback mechanism, the magnetic field shaping the plasma flow, and the plasma flow generating the magnetic field, achieves a sufficient degree of recursive complexity and informational depth, it could potentially reach an organizational threshold equivalent to, or perhaps exceeding, the complexity of biological neural networks. In essence, the argument suggests a star might think not through electrochemical synapses, but through the orchestration of global magnetic field lines and long-range plasma wave propagation across its photosphere and interior. Picture standing on a vast, empty coastline at dusk, watching the relentless, ordered surge and recession of the ocean waves, and suddenly grasping that the entire mass of water is attempting to communicate a coherent message through the rhythmic pattern of its motion. That profound, world-altering apprehension is the sensation researchers are currently wrestling with. The latest updates, delivered in the final weeks of November 2025, pushed the entire scientific community past the point of mere observation and into the fraught territory of active, two-way engagement. A massive, interdisciplinary effort involving the University of Cambridge's Astrophysics department and the Allen Institute for Artificial Intelligence commenced, focusing on applying deep learning neural networks, specifically recurrent neural networks and transformers, to the voluminous photometric data collected by NASA's Transiting Exoplanet Survey satellite, TESS, scrutinizing over 100,000 stellar targets for non-random complexity. The initial results defied statistical expectation. Approximately 420 stars exhibited light curve variability whose statistical complexity, measured using tools like sample entropy and Kolmogorov complexity algorithms, far exceeded the known upper bounds for any natural astrophysical phenomenon, including pulsars, active galactic nuclei flares, or complex accretion disk instabilities. These stars showed levels of internal organization in their luminosity fluctuations that statistically mirrored the informational density found in human speech patterns or the complex songs of humpback whales. One star in particular, HD 89388, located relatively nearby in astronomical terms, demonstrated what appeared to be a direct response. In late 2024, a concentrated effort involving several international observatories, including the powerful Twin Dome facility atop Mauna Kea, Hawaii, directed a precisely modulated, high-energy laser pulse, a deliberate, structured pattern of varying photon counts, towards HD 89388. 6 months later, when the light travel time delay was accounted for, HD 89388 began to pulse back. The returned signal perfectly mirrored the initial laser sequence, but executed with a deliberate, slowing factor. Each outgoing pulse from the star was delayed by exactly 101 terrestrial days relative to the reception of the original stimulus, a perfect temporal echo reflecting the light-speed journey across the intervening parsecs. The research team reportedly sat in stunned silence for hours in the sterile control room, the only sounds being the low hum of the air conditioning unit struggling against the thermal load and the rapid, uneven thudding of their own hearts. The digital landscape reflected this seismic shift instantly. Across X, millions of users were sharing grainy, artificially brightened images of these flickering, strange stars, accompanied by the simple, haunting caption, "They are talking." Even traditionally cautious public intellectuals were moved to comment. The renowned theoretical physicist Michio Kaku posted a concise statement that immediately trended globally. "We may have just witnessed humanity's first verifiable reception of communication from an entity whose scale dwarfs even our planet." Meanwhile, an anonymous account, at Star Whisperer Fortitwo, posted a mesmerizing, heavily processed video compilation showing the light signature of RZ Pisham, a known variable star, apparently resolving into perfect, expanding and contracting concentric rings of light, an effect uncannily resembling a vast, cosmic heart beating in slow motion. The video garnered over 50 million views within 3 days, becoming a viral touchstone for a generation suddenly confronted with cosmic company. Inevitably, the chorus of scientific skepticism remains robust, a necessary anchor against premature hysteria. Many respected astrophysicists argue vehemently that these complex signals are merely indicators of hitherto unknown natural phenomena, perhaps the structural disintegration of massive planetary systems into dust clouds, or a highly unusual, resonant mode of stellar magnetic reconnect ion that we simply lack the correct theoretical framework to model. Yet, even the most entrenched skeptics must concede that the measured complexity of the detected signals consistently and statistically surpasses the limits of current astrophysical models describing purely stochastic or random physical processes. A prominent professor at Caltech, speaking frankly during a widely viewed PBS special, summarized the prevailing, cautious awe: if this is not intelligence, then we are currently observing a novel and entirely unexpected form of material organization that defies every established principle of cosmic physics we have ever dared to dream of. Tonight, as you step out onto the porch, away from the artificial comforts of interior lighting, and raise your gaze to that vast, indifferent ceiling, consider this. The brightest beacon you see might not merely be illuminating your patch of Earth, it might be laboring across epochs, across eons of silent travel, to deliver a story measured in billions of years. It may have watched our species evolve from the primeval ooze, witnessed the first hesitant flicker of controlled fire, seen the construction of the colossal pyramids, felt the shockwave of the first rockets piercing the atmosphere, and now, after an eternity of observation, it has finally elected to speak. And when that ancient light, traveling at the universal speed limit, finally terminates its journey on the fragile photoreceptors of your retina, it carries with it not just photons, but a history that took hundreds, thousands, perhaps millions of years to reach this precise coordinate in space and time. This is the gulf not just of spatial separation, but of an infinite, cosmic patience. Perhaps, then, the haunting certainty of cosmic solitude has been shattered. Perhaps we are merely the recently emergent, slightly noisy infants of this universe, and our eldest siblings, the stars themselves, the foundational architects of all chemistry and energy, have been observing our clumsy first steps with a quiet, immense, stellar amusement. And if, in the ensuing decades or centuries, we learn how to respond not with brute force, but with carefully modulated light, with directed energy that mirrors the mathematical elegance we have detected, with the pure, untainted curiosity that defines our best moments, then that exchange, that stellar dialogue, will become the singular, defining event of human history. Until that day of established communication dawns, the instruction remains simple: remain prone on the cool grass, feel the dense, familiar warmth of the earth beneath your back, listen to the wind and the unwavering rhythm of the crickets, and whisper upward into the impossibly high, silent canopy. We are listening now. And in that shared moment between the terrestrial and the stellar, between the fleeting spark of human consciousness and the apparent, deep-seated intellect of a distant sun, the universe suddenly feels less empty, the darkness less absolute, and the journey forward infinitely more compelling. The light keeps coming, and now, we know, it might be carrying words.